Good morning. When the iPhone first came out, it really had this premium feel to it. I don't know if you remember it. It was just kind of magical. And there are lots of factors that make it feel like that. I think one of the big factors that I really liked was the way the animations work. So specifically, I really liked Scrollviews. If you saw the scroll view on an iPhone, it was different, right? Like you scroll and it's so smooth. And then as you let go of the scroll view, it sort of slows down. And so there's this sort of naturalness to it. And then when you get to the end of the scroll view, it bounces a little bit. So this little animation. And I think these are the things that made the iPhone really special. And if you think about the highest quality apps you've seen, there are so many that really have these great animations. And I think that's what makes like the final bit of an app and what makes an app really special and really sort of premium. So that's what I want to talk about today, animations in SwiftUI. And at first, I thought animations were pretty magical, actually in a bad way. But then I tried to understand how they work. It took me a while, but now I think they're really nice. So that's what we're going to look at. So let's get started without any animation. So we're just going to draw a rectangle. And we'll learn some things about SwiftUI as we write this application. So one of the interesting things, I think, is if we write rectangle, we don't have to provide any configuration. It just fills the entire screen black. And it's something to keep in mind. So the rectangle basically fills up all the entire space. Now, let's make it pink. So we can say fill color that pink. And now, of course, we'll get a pink rectangle. And this is already a little bit different. If you use the UI kit, it's a very different kind of syntax. We don't configure the rectangle in a normal way. We just call these methods on a rectangle. And let's make it a little bit smaller. So here we'll use frame. And we'll make it 200 by 100. And this is also a little bit different. A frame is just about the width and the height. And by default, SwiftUI will just put it in the center. OK, so that's how we can make a pink rectangle. No big deal. The syntax is a little bit funny, but that's it. So now let's try to add some animations. The first thing we'll do is add some state, because we need state to drive animations. So we say state var. Let's, for example, select the rectangle. So say the rectangle by default is not selected, false. And then we'll add a button. And in order for this to work, we need to tell Swift how to combine multiple views. So we'll put them in a VStack so that they'll end up below each other. OK. So inside the button, we can now change that state. So for example, we could use this nice method and say self.selected.toggle. And this will toggle between true and false. And then for the label, we can write text, let's say select. So if we run this, nothing will happen. We can tap the button, and it sort of shows that it's being tapped, but that's it. But we don't actually select anything. And the cool thing is that the Boolean is being toggled. We just don't see it. And one of the things I really love about SwiftUI is the way we can observe changes. So by using stuff like addState, we don't have to think about observation. We can just use those values in our views. So for example, we could say, well, if we're selected, then we'll show the text deselect, otherwise select. And what happens now, as we tap the button, the state changes. So the selected state changes, and the view gets re-rendered. So now we'll see that the text changes. And this is already, I think, a key point in how SwiftUI works. I don't know how it works internally, because I don't work at Apple, and the people who do work there are probably not allowed to talk about it. So I can only tell you about my mental model of how I think it works. So what I think happens is the moment the state, or actually the moment we start rendering, what happens is this struct value, this VStack with the rectangle and the button, it gets sent to SwiftUI. And SwiftUI does two things. So on the one hand, it renders all the views on screen. That's what we see. On the other hand, it keeps the value of that struct in memory. Then as we change the state, it re-renders, and it compares the new value against the old value, and it tries to update only what's necessary. So in this case, the only thing that really changed is the text of the button. So that's the only thing that's being updated. And now let's add some animation. So let's say, for example, we want to have a green rectangle. So we can say color.green and use the selected. So if we're selected, we use color.green, otherwise pink. And if we do something like this, we don't really need an animation. It's very clear to the user what's happening. Like as I press it, the thing becomes green. But let's add a little bit more stuff to it. So we could say, for example, selected will have a width of 300, and then we'll have an offset. And for the Y, we'll say, well, if we're selected, we'll do minus 300, otherwise we do 0. Now I think it becomes much harder for the user to see what's happening. As I press select, there's a green rectangle there. And of course, your brain fills in the animation a little bit because there's not much on screen other than the rectangle. But as you have a more complicated app, I think this is one of the places where you could add an animation. So let's add an animation. So that's all we need to do. Thank you for coming to my talk. OK, so this is magical, right? Like, we don't have to do anything. We just write animation default, and it animates. How can that work? And this is, to me, it feels like the wrong kind of magic when I first saw it, because I didn't understand how can it work? And is it like introspection or what's happening? So the mental model, again, is this. As we change our state from selected false to selected true, SwiftUI knows, OK, so previously I had this little pink box, and now I have to have a larger green box. And it tries to compute the difference between these two boxes. And then it tries to animate those changes. And it does this sort of per property. So it looks at the color, and it needs to animate that color from pink to green, and from green back to pink. And it does the same for the width and for the offset. And then it combines all those into one animation. We can see what's happening a little bit clearer by changing the interpolation function. So we can say default, and then let's say the speed at 0.1, so 10% of the speed. And now we can see that it really animates each of these changes individually, but combines them into one big animation. And we can go back. OK, so to understand what's happening here and how this can work, I want to dump some stuff. So I want to understand what happens when I write rectangle and when I write fill. So to dump stuff, we can do that on the console, but it's more fun to do it inside the simulator. So we're going to write a little struct for that. And we'll initialize this with any value. So we can say value A. And then instead of just doing dump value, we can do dump 2. And here we can pass in some result string. So for the result string, we'll say var result equals an empty string. And then we'll make this thing a view. So we can say view. And then here we say var body text, and then return text with that result. And now we can dump stuff onto the screen as text. So over here, we can say, for example, dump rectangle. And now let's see what happens, because I think it's already very interesting. What we'll see on the screen is just rectangle. And unlike something in UIKit, this rectangle, if we go into this, it doesn't have any properties. There's a method path in rect, and that's it. And there's animatable data, but it's empty. So this rectangle is really that. It says you need to draw a rectangle, nothing else. It doesn't say anything about the color, about the size, or about animations. And I think it's a key thing to understand how things work in SwiftUI, because once we add the fill color, for example, and let's say color that pink again, now if we dump it, we'll see that there's another layer. So it's a little bit hard to decipher, but here's a shape view that contains the rectangle. So the rectangle is part of that layer. So there's like a layer around the rectangle. And that layer says whatever you put inside fill it with pink. So if we would have had a circle in there, it would be a shape view of a circle. So that layer sort of provides the context for drawing. And we can go further. So we can say, for example, .frame, and say, well, the width is 200 and the height is 100. And now we'll see that we'll have another layer around a rectangle. And this is why all of these things return a sum view and not the real type. So we can see up here, the first two lines, that's the type. So we have a modified content of a shape view of a rectangle that's filled with a color, and the modified content has a frame layout. And my mental model of how SwiftUI draws these things is that it starts at the outer layer. So it starts with this frame, and it says, well, I don't really care what input size or input frame I get, as long as my content is going to draw itself in 200 by 100. And then we'll have the pink color. So that says, well, I don't really care what kind of shape you draw, but it's going to be pink and still inside this frame. And then we draw the rectangle, which just fills up the available space. So that's sort of how it works. And now for the animations, it's really interesting because these animations, they work by animating the individual properties of these layers. So each of these layers, in this case, conforms to animatable. And that means that SwiftUI can get some animatable data, inspect it, and work with it. So it can, for example, like maybe the fill layer, it has this color property. In SwiftUI, I can see, OK, there's an animatable data, which is the color, and I can see the difference between the two colors and then animate my way from green to pink. OK, so let's make a little bit more complicated animation, which should be easy. OK, so I'll go back and make this example a little bit simpler. We don't need an offset for now, and I'll remove the dump. So we'll go back to a normal pink rectangle. What I want to do is shake this rectangle. And that's tricky, right? Because before we were just automatically animating between values. So what do we animate here? What values do we set to shake this thing? So we can start by doing something like this. We could say, well, OK, the offset, if we're selected, so the x offset, if we're selected, is going to be -50, and otherwise it's going to be 0. And let me remove that speed. And now, of course, as we tap the button, it will not really shake, but just move to the left. Yeah. So we could repeat this animation, for example. So we could do something like repeat 5 times. And now the animation will go back and forth. So it's sort of shaking, but then it ends up a bit to the left. I don't think the designers are going to be happy about that. So I mean, we could further improve this still. So we could do something like speed 5, and then we have the normal duration of the animation, and it shakes a little bit. Maybe a bit too much, but it ends up to the left, and that's not what we want. So if we would change this back to 0, then there's nothing to animate. Now it ends up at the same position, but it doesn't animate anything. So what do we do? And this is where I was a bit frustrated with SwiftUI, because I didn't really understand what was happening. So it turns out that the solution is adding another layer. So we need to add another layer that does the animation for us. So let's do that. So we're going to create a shake effect. And as a sort of a shortcut to create a view modifier, which is what we'll need, I'll use a geometry effect. And geometry effect has basically one requirement, and that's that we implement an effect value. And this wants us to return a projection transform. And that's, well, we'll start with an empty, and then we'll look at what a projection transform is. So this compiles. Now, instead of the offset, we'll use a modifier. And here we can now create our shake effect. So of course, this won't do anything, but at least it compiles. That's a good first step. So what's this effect value? So this is either a 3D transform or a normal 2D transform. And we can create a CG affine transform and pass that in. And here we can do stuff like rotate, scale, or anything you can do in these transforms. So for example, we could do a translation of -50 on the x-axis, and now our layer will move that thing. OK, so we need some way to modify this minus 50 during the animation. So for example, we could think of, let's animate from 0 to 1, and as our x moves from 0 to 1, we want to animate that thing. So I think a sine function might help us here, but I'm not really good at these math kind of things, so I'll use the grapher. It's a built-in app if you've never used it. And here you can just play around with formulas, and I use it a lot when doing these kind of things. So we could say, for example, the sine of x, and now we see a graph of the sine of x. But what we want is this animation or this sine to go up and down, not in 2 pi, but in 1. So from 0 to 1, it should go up and down. So probably we need to divide or multiply it by pi. So that helps. Now it goes up and down, not from 0 to 1, but in between 0 and 2. So we need to scale it a little bit further. So let's do times 2. OK, so that's exactly what we want. So let's use that. So the translation will use the sine. And now we need some value to animate. So let's say position times 2 times pi. And this value is just a property that we can add. So we can say var position is a CG float, and we'll start at 0. And now over here, we could say, well, position is going to be, if we're selected, it's going to be 1, and otherwise it's going to be 0. And this should almost work. So not much is happening. And that's because the position isn't part of the animatable data yet. And that's what we need to add now. So by default, a geometry effect has an animatable data that's empty animatable data. So you can see it here. This is the default type with a default implementation. We want to use a CG float. And for the getter, we want to use position. And for the setter, we want to set the position to the new value. OK, so now let's run it again. And I think we should see an animation. OK, I don't know who saw it, but it moved just a little bit, right? 1 pixel. So that's an easy fix. So we can just do like 30 times. And now it will move not from -1 to 1, but from -30 to 30. So it animates. That's nice. And one of the things we can do, which I think is really interesting, is to see if we print the position, we can see what's happening under the hood. So let's open up our console. So by default, it has a position of 0. And then when I press select, it moved the position actually from 0 to 1, back to 0, back to 1, back to 0, back to 1. And the reason why it does that is because we still have this repeat count over here. So if we would have a default animation, for example, then it will just move from 0 to 1. So let's press select. And now we can see that it moves from 0 to 1. So what's happening here is SwiftUI knows that it can take that animatable data from when the animation started, and then from our goal value, which is 1, and then it can interpolate between those two values. So this is what does the interpolation, the animation at default, and it just multiplies that position. And that way, it computes the position, so it computes a position from 0 to 1, and we can use that in whichever way we want. So one of the things I want to do to finish this is, now, this animates just once. Let's go back to our grapher. I want to animate it maybe more than once in between 0 and 1. So again, let's say if we want to animate it 3 times, we can just write times 3, I think. Yeah, and now we have 3 of these things in between 0 and 1. So let's add that over here. So number of animations equals 3, or number of shakes is maybe a better name. And then we can add that here as well. Number of shakes. We could also solve this in a different way by incrementing the position not from 0 to 1, but from 0 to 3, for example, and then it also shakes 3 times. So what I hope to have showed is that it works differently in SwiftUI. If you're used to UIKit, you really need to relearn how to create these views. At least I really struggled in the beginning. And especially when doing animations, you cannot just add an animation and think it will work, because by default, SwiftUI will interpolate between these two values. And if you want to do something like this, shake animation, or move something along a path, then you really need to have a custom layer that wraps around your entire view and does the animation for you. So I hope you're inspired, and I'm very happy to take any questions you have. Thank you.
Thank you. Daniel, you can join us here. Chris is going to join us also here. We're going to have a short Q&A session. So take a seat, guys. So don't forget to ask your questions during the talk through Twitter.
Can I make a comment first?
Yeah, sure.
So Chris's talk was awesome, but one of my favorite moments in it was in the beginning, where he took the bool and he called toggle. It was one of my favorite moments because toggle was added to Swift because of Chris.
Yeah.
Huge impact on developers all around the world.
So make sure to have your mic really close. Just one word to the classroom teachers. Make sure to join Mathilde down there, and you're going to be able to present your classroom in a few minutes, right after.
So I can go?
Yeah, you too. One word about us, like my name is Mathieu,
and mine is Simone.
So we are hosting and we're presenting and asking the questions to the nice speakers.
Are we going to redo the intro?
Maybe not. So those technologies have been kind of a big surprise for a lot of people. Like we were not expecting things like that from Apple. Are you happy with those new technologies? Are you happy with this shift in Apple paradigm?
I really am, and I got to say, some people were very clear. Matt Gallagher had a blog post before DubDub where he called it almost exactly. It was just a beautiful exposition of what he sort of saw would be natural.
Yeah, that was kind of late, like for years. Like
late?
Yeah, yeah, right. You never know, but like previously was more really confidential technologies. A lot of people were actually working with RX Swift or technologies, similar technologies. But now Apple has made that available to the whole public. And do you think it's going to be accessible to everyone? Like, isn't the learning curve too deep for some of us?
What I think is Apple's ecosystem is such that when Apple says, here's the way we're going, we go. Yeah. And like the Swift Package Manager compared to Carthage and CocoaPods, once it's a first-party thing, we go. And so there are people that are going to have to support back for a couple of years, but in a couple of years when people are saying, okay, we can support iOS 13 and beyond, it's so clearly the way Apple is carving out.
So I think another interesting thing is that the way, well, if you look at SwiftUI or Swift or whatever new technology, it's a little bit harder maybe for people who are already used to the ecosystem than people who are completely new. If you're a beginning developer, everything is difficult in the beginning, or at least I think so. It was for me, and then you learn something and you just do it, right? But if you know how to do, for example, animations in SwiftUI, or in UIKit, and then you need to do it in SwiftUI, and if you're like me, you're going to be frustrated because you knew you could do it and you cannot do it anymore. So you have to relearn and you have to change your mental model, and it's almost the same, but then quite different. And so, yeah. Yeah,
the problem is that you know how to do, so you do the old way, so you don't have like a real opportunity to learn and to like get the new paradigm.
Yeah. A nice thing is that everybody is back to the beginning in a way. So I guess new apps will be able to have new juniors in the project, because everybody will be like at the same level now.
Yeah,
we're
all junior.
To me, when I first saw SwiftUI, the code we saw from Apple, everything was sort of together. And now that we play with it and we see how different people are breaking it out and making it simpler to work with, it's much nicer. But I would like to see more examples, more documentation from Apple.
A question which is related to what you were saying about like complexity and learning curve. How do you make sure the code base stays like readable for new people getting into the a new code base? Because with those operators with lots of combine, I guess the understandability is that a word of the code base can be negatively impacted in some ways.
So I think Daniel's talk just showed that well, where if you use things like map that everybody knows probably by now, then that helps understandability. And then there are other operators in Combine that are more difficult to learn, but as you learn them, all of a sudden it becomes simple, and then the code is actually easier to understand. And I think it's the same with some of the things in SwiftUI. And understandability is really hard to define, I think, because it's very personal. And now that Apple has sort of blessed Combine, we're all going to learn it probably, and it will be easier to understand than manual things. But first, for the people who don't know it, it will be hard to understand. But once, like if you look at like 5 years from now, and maybe 8 out of 10 apps use Combine, then that's really helpful, because then you don't need to know like what framework is just Combine, and you know it, and you've used it everywhere. So it's very difficult. Like in the beginning, it's going to be frustrating, but hopefully in the end, once we have a single technology, it will be easier to understand.
And I hear a lot from people that say, well, but this is way more intuitive, it's easier to understand. But I remember when OO came around and people didn't want to do that because that was too hard. And now people think, well, that's the natural way. There's no natural way. There are all ways of us partitioning problems.
OO is objective programming, right?
Object-oriented, yeah.
Oh, yeah. And so, as you were saying, like RX and other previous approaches were a bit hard because you were not sure that the new programmers would know that. And it seems that those new technologies can be adopted in existing apps gradually. And do you have some advices or some visions on how to actually embrace gradually in the code base, but also in the mindset of the programmers? How would you address that? How would you introduce those new technologies in existing apps?
So my job, day-to-day job, is just writing example code, right? Like small example projects. So
dream job, right?
Yeah, and I love it. Like it's the best thing. I get to play around with these animations for a long time and see how it works. But I don't really have to work on scaling apps anymore. That's a very different problem, and that's like probably most people in the room know way more about this than I do. So I would ask somebody in the audience, because it's very hard to answer for me. Yeah.
So if you have tricks, then you can submit them to Twitter and add an hashtag FrenchKit and maybe Chris Eidhof so that he can learn from you.
We've got 2 questions from our audience. The one being, what are the advantages of Combine over RX Swift and RX Coco?
The main advantage is it's a first-party API. People have complained that there are things that are in RX that aren't in Combine, and there are things that it doesn't seem that Combine engineers have considered yet. But the integration with the Apple APIs is a huge advantage, and it's just a matter of time before, unfortunately, things like this, it's just going to win.
Yeah, sure. And of course, the question that everybody asks, is all of this production ready? So if we like target an iOS 13 only app, can we go with it?
Or 13.2, right?
Yes.
Well, you just need to stay seated and watch Thomas's talk. He can tell you. He shipped a production app.
Yeah.
And I think it's, well, so if you do SwiftUI, you can totally ship with that, I think. We shipped a Swift app when Swift first came out, but you need to be aware, like things are going to be broken, you get a new version, you need to fix everything. So you don't have the same, like you have different problems. You have like less code and everything is nice and SwiftUI, but then you have these upgrade problems. When you do UI kit, you don't necessarily always have that, but then you need to write a lot more code. So it's really a matter of what you want. If you like being on the edge, if you really want to be sure and certain, like use a boring technology, it's way safer. But if you like having fun and you can in your job, and then why not? I would ship with it, but I don't really ship production apps so much as most people. So
You ship live coding with it, right?
So also something that Apple released. So this dub was huge, and collection views and diffable collections were huge this year. We don't see any of that in SwiftUI. And so there are some things that people think are important to apps that just don't ship with it.
So maybe one more thing to add to SwiftUI, if you're going to use it in production, you can always drop down to UIKit, so you can do certain components completely in UIKit. You can even use them straight, like as you have them, and you can sort of mix and match, so you can always fall back on that. It's maybe a little bit of comfort. It's not going to make everything easier, but at least it helps a little bit, I think.
And the integration is pretty nice.
But there's this production-ready question, but it's also about like, should I learn that right now? But is it wet? Will it change a lot? Because sometimes you learn a new technology and then it changes so much. I mean, Swift at the beginning, it changed so much that learning it from day one was probably not the best way to be really effective. How do you think it's going to change over time in the few first months or years?
So I think with SwiftUI, it's going to get sort of wider in a way. So there's going to be more components and stuff like that. I don't know how it's like in what ways it could go deeper, where like it's a different model. Still, like if the people who've been following along with the betas, like a lot of the names changed, like the observable object and so on. So a lot of there's still a lot of naming changes, but it seems like the concepts have stayed the same, even though now they work a lot better. Like they fixed a lot of bugs, but I don't know. Like I don't see. It's hard to predict. I don't have a what do you call it?
Crystal ball.
Crystal ball. Yes.
So I think one of the biggest things I look for is the same thing we saw in Swift, which was Swift changed, but even better, the tooling changed. And if you remember, dealing with errors in the early days of Swift were very hard. We're seeing that with SwiftUI, where. And it's partly because SwiftUI has changed so much that building the tools around it. So I think we're going to see better error messages and more helpful that way.
Yeah, and you were saying that the documentation is probably not like really great.
You're being
yet.
much nicer than I was.
I'm trying, but
I didn't say probably at all.
And what, in your opinion, that's actually a matter of opinion, of course, is will be the versioning model, the versioning approach? Because Swift was kind of Swift because it's a language, so you just have like Swift 2, which is not compatible backwards, but with a framework that's different. So how you make sure that how, in your opinion, will Apple make sure that they won't have breaking changes? Do you think they will have like combined two versions, not backwards compatible?
I imagine there will be breaking changes. I don't know, like but hopefully not. But I think there's a good chance that things might break. But if your app is big enough, maybe Apple will look at it before they push an update. But I think there's a good chance. At least my app broke. Well, not in the recent betas, but in the first few betas, it broke all the time.
But this happened in Swift 2. The transition from Swift 2 to 3 was very painful.
Yeah. Yeah, and that was clear with the real version
But I think
number.
looking back, I think that's good. I think the Swift we have now is really good because they were willing to make those changes.
Absolutely.
And when Apple's developing SwiftUI internally, and then they get to see how it's used in the wild, I think they learn a lot from it. So I don't mind that they break and they make it better.
Yeah, it's just a decision where do you jump in. Just a quick question about the tool that you used, like this really old macOS 10 tool to graph the functions. Can you tell us a bit more about that?
Yeah, I use it for these kind of things because I'm bad at math and I need to visualize it. So if I see like, okay, here's a sign and it goes back to 0 to pi, I know, okay, I need to somehow compress it this way visually, and then I just try around until I find a good function. And I mean, this wasn't perfect, but it does the job. And yeah, the tool is awesome. It's called Grapher and it's built in, so you can just start it now.
Yeah, it's installed by macOS 10. It's in utilities, I think. Applications in utilities.
It's production ready.
This one is production. That's the only one that's production ready, maybe.
Yeah. Actually, that's a nice how to say clin d'œil. So you're bad at math, you said, and there is a class from about math and functional programming this afternoon with Daniel. So yeah.
Awesome.
Wow, nice. thank you very much, guys.
Thank you.
Thank you for your time.